Okay, we are moving into kinetics, the branch of mechanics focused on the forces causing movement. So we are into kinetics, the branch of mechanics, interested in the forces causing movement. Now, in this module, I'll define what a force is, but it's basically a push or a pull that tends to cause movement. It doesn't have to cause movement. Push or pull that tends to cause movement. All right, remember we defined movement as a change in space over some time period. So that's our kinematics. And so what we're really interested in is we're interested in what's causing kinematics, what's causing movement to happen, what's causing position to change in some time period. And so there's this nice link between kinetics and kinematics. And this is why I spend a lot of time at the beginning of this course trying to understand kinematics, in particular PVA, position, how to quantify position, how to quantify position both with displacement and distance, how fast position is changing by studying or understanding velocity, and by understanding how fast velocity is changing, and that's acceleration, time rate of change of velocity. And we do this both for the linear and angular worlds. Linear and angular worlds, okay? So once we have this understanding, we can then try to work towards understanding the forces causing a change in position, the forces causing velocity to happen, and the forces causing velocity to change. So once we do that, we are in the branch of mechanics called kinetics. And the equation we're going to work with primarily is Newton's second law, F equals ma. I'm sure you've heard of this law. And what this law basically states is the forces, if we add up all the forces acting on the object, we can understand the product of mass of the object, which we'll learn as inertia, the resistance to change motion times acceleration of the center of mass of the object. Okay, so we're going to talk about center of mass down the road as well. So what we really have is we have kinetics and we have kinematics. Whoops, and M is not kinematics, really acceleration. And so I like to spend a lot of time working on understanding acceleration. Because if we can understand acceleration, we can understand the forces causing that acceleration. All right, so basically, what we're going to be working on is we've got some object. That object will not move until something comes along and causes that object to move. That something is a force. All right, so that's Newton's first law. You'll learn Newton's second law. It defines what a force is and what the force does to the object's kinematics. And Newton's third law actually tells us for every force pushing on an object or pulling on an object, there's an equal and opposite force. And we'll go through all those details quite a bit. So if you see no change in velocity, that means one of two things. Either there's no forces acting on the object because acceleration will be zero, or all the forces acting on the object add up to zero. Either way, all right? Either no forces acting on the object, or, and most likely what we're going to be dealing with, all the forces acting on the object will add up to zero. So for example, if I push here and I push here with equal forces, that object's not going to move. And those are two forces acting on the object in that direction. They add up to 0. All right. Now, if we see an object change velocity, all right, if we see it change velocity, okay, I pushed it, I gave it some velocity, and then eventually it stopped. So it went from some velocity once it left my finger to 0 velocity. That means there's a force causing that change in velocity. That means there's a force causing that acceleration. And that's what we're going to set out to, is to understand the forces acting on the object that ultimately cause the object to move. And we'll deal with forces in the linear sense, like what I'm talking about now, as well as forces in the angular sense, where we have some rotation. And we'll learn that that's called a torque. So kinetics, this is the linear form of this equation. The angular form is we add up all the torques acting on the object, and we get the product of moment of inertia times angular acceleration. And I hope you see the parallel with these equations. So all the torques acting on the object about some axis of rotation, and I'll get more into torque later on, but it's the measure of the tendency of the force to cause rotation. Moment of inertia is analogous to inertia just in the angular sense, and we'll go through this parameter in more detail, but it's resistance to change angular motion. And then finally we have our angular acceleration, which we should recognize from our angular kinematic section of the course. And now we see this equation is in essence the same equation, just in the angular world versus the linear world. All right, so the reason why we spend a lot of times working on understanding kinematics is because the kinetics are tightly related to the kinematics. And now we just need to understand this other parameter here, which is inertia and moment of inertia. So they're linked, and they're linked in a way that if we can see things, we can understand the forces causing the movement. Sometimes it's hard to envision the kinetics, although it's a little easier nowadays with some of the instruments we have. We can see results or forces based upon different sensors we put on an object, or have the person walk over or run over or jump on, what have you. But this is often harder to envision the forces, and it's tightly related to acceleration, both in the linear and angular world. And we know from previous lectures that acceleration is the most difficult parameter to understand, primarily the direction of the acceleration vector. Okay, so this is our link. We're going to launch from kinematics and go right into kinetics, and we'll do the linear kinetics first, and then we'll do the angular kinetics first, or second. Okay, thanks. I hope that helps give an overview of where we're going. Thanks, everyone.